What's up, gangsters? And yeah, welcome back. If you've been suffering through this whole foil adventure, yeah, you deserve a beer. If I could give you one right now, I would. But how about this instead? How about this right here? You can see some things reflected in that piece of aluminum. This is where I've been trying to get. So let's get into how I finally got here. Okay, so as promised, I did get the thicker foil, I did put it on, and we'll discuss the results. But first of all, just real quickly, so you can see this. All right, this is the Reynolds Wrap heavy duty foil. Got myself a giant roll, enough to do, yeah, like 1,000 models. The difference between the heavy duty and the regular duty is about 20%. That stuff is, the heavy duty stuff is about 0.00085 inches thick. So about 85% of a mil. A mil is 1/1000th of an inch. Just to give you perspective, for those of you not using primitive units, 1/1000th of an inch is, let's see, 4/1000 is 1/10 is 0.1 millimeters. So you're at about 0.025 millimeters, I think, if I can do math in my head real quick, which I usually can't, so that's probably wrong. Anyway, so it did make some difference, but I'm still not really happy with the results because it's still not where I want to be. You can see, okay, I did this using what we'll call the Gin Right method. I put the adhesive on with the brush. It did have some brush strokes showing up, but it sanded out relatively well. I was actually pretty surprised by that. And I really don't have a lot of the orange peel texture. So that's good. And the way that I decided to sand this one, I mean, you can definitely see some orange peel. If you look at the fringes of the reflection, that's where you see the texture the most. Okay, but that's what I'm up against. It's reflective enough, but there are just too many scratches. It's just not there. But the way I sanded that one is I used my Proxon. I had this, I don't know, I think this may be a piece of 400 grit sponge. Did it dry just to knock down all of the major ridges, got it all nice and flattened out. Then I hand sanded it the rest of the way using 600 grit paper all the way up to 2500 grit Infinity sanding stick. Then I polished it using, same thing, Proxon wheel, Mother's aluminum polish. Now, there are some people who say Mother's sucks. I don't really understand that. This stuff has been popular for decades. It can't be all bad. It's specifically formulated for aluminum before somebody says, go and use the Tamiya compounds or whatever. This is aluminum polish. And until somebody can tell me exactly why it sucks or what's better and why it's better, this is, I think, we should be able to expect that this is going to do it as good as anything will do it. But some people might also say, well, you're just not sanding it properly. You're just not doing it right. And look, I don't get offended by that because I probably honestly would think the same thing if I saw these results knowing what I know. I have polished, machined aluminum to a mirror finish. It's not that hard. And so that's part of why this has been so frustrating for me because I just can't get the same result. And I've been talking to Gin Right quite a bit and some other people, and a couple of ideas have come out. I still think we got a glue issue. I think part of what happens is that because the glue is flexible, you're doing that whole, mash it down, it pops back up, and you're playing whack-a-mole, and you're just, never going to get it. But I also think that part of what's happening here is that this alloy is just so soft. It's like a clear coat that's too soft. If you've ever tried to sand and polish a 2K urethane clear gloss or a lacquer clear gloss that's just not really super hard, you know that it's almost impossible to get all the scratches out. It seems kind of counterintuitive, but the harder the thing is, the better it polishes. I mean, look at diamonds. But let's just have a quick lesson in aluminum alloys here real quick, so this will make a little bit more sense. Aluminum alloys are numbered in a series. And what you have, okay, if you look here on my phone, what you have is a series that goes from 1 through 8. You got 1000 series, 2000 series, etc. And each series indicates what the stuff is, what the alloying elements are. So like 1000 series aluminum is basically pure, 99% pure aluminum minimum. It doesn't, it doesn't really get used for a whole lot of things, except foil, which we'll talk about. Well, I'll just go ahead and say aluminum foil is typically Al1235. That's the alloy that aluminum foil is made of. Other alloys, the 2000 series. If you're an aircraft modeler, you've probably heard of 2024 aircraft aluminum, also known as duralumin in some circles. It's been around forever. Its major alloying component is copper, and it's really strong and hard and tough. The other ones you can see. Now, 6000 series aluminum is the most common commercial structural aluminum for machining, sheet aluminum, all kinds of things. And you can see that its major components are magnesium and silicon. 6061-T6 is the most common aluminum alloy for everything. And the T6 stands for the heat treat condition. And that's not fully hard, but it's way harder than dead soft. Now, just to put hardness in perspective, okay? So what you got is on a hardness scale, there's different ways of measuring hardness. There's the Mohs hardness scale, there's Brinell hardness, Rockwell hardness. But 6061 T6, 95 on the Brinell hardness scale. Pure aluminum is around 30 on the Brinell hardness scale. So you can see that it's substantially softer than the kind of aluminum, for example, that is machined and polished to make the handle of this X-Acto knife. To compare it to something else, on the Mohs hardness scale, pure aluminum is about 2.75. Gold, as it comes out of the ingot, is about 2.5 on the Mohs hardness scale. But pure gold is never used in jewelry because it's too soft to be practical. And so they add white gold to it to make it harder and bring it up to around 4 on the Mohs hardness scale. So for those guys who are like, well, they can polish gold, why can't you polish this aluminum? Well, okay, you got Mohs hardness of 4 versus some Mohs hardness of 2.75 or 3. That's a substantial difference, and it certainly would make the difference. So if in fact the hardness of the foil, or the softness rather, is the culprit, so then my next idea, because engineer, right, is to go and look here, who makes aluminum sheet and foil in other alloys? And so I found these guys, All Foils. And they do in fact have all kinds of sheet and foil, different alloys. You can see they make thicknesses of aluminum foil that gets clear down to 0.0002 mils, way thinner than what I need, and all of these different alloys. So it's a Saturday now. I'm calling these guys on Monday and seeing if maybe I can get some samples of some foil that's going to be harder. And the question then is it going to conform? The fact that this stuff is dead soft and you can push it around so easily is a big part of what makes it workable, literally, for this type of application, but at the sacrifice of polishability. Yeah, I don't know. We'll see. I'm always looking to try new things, so we'll see what happens. In the meantime, to address the concerns about sanding it, I'm going to do this again. I'm going to see if I can sand out the scratch marks here. And what I've got on this, so what I've got here is I've got all of these little pieces of Abralon sanding pads. Okay, these are sponge pads. These are 500 grit, 1,000, 2,000, 3,000, 4,000. And if you're not familiar with Abralon stuff, this is automotive grade refinishing stuff. They make these pads with the, to use with the hook and loop orbital sanders. Mirka is who makes it. It's kind of unique because it's got this cloth with abrasive impregnated into it on the working surface. So this is the legit stuff. This is not just some, random abrasive. But nonetheless, so what I'm going to do is I'm going to start with the 500, and I'm going to and I'll speed this up because ain't nobody wants to watch this in real time. So get this thing fired up, and I'm going to do it dry. Okay, somebody's going to say, well, you get a better finish if you do it wet. Yeah, not necessarily with metals. It's not as important to wet sand metals because they're not soft and gummy, like resin or plastic, for example. And what the water does when you wet sand with that kind of material or with paint or whatever is it washes the grit out of the abrasive grains, so you get better cutting and your paper lasts longer. Not as much of an issue with metals. So just to make it quick and easy and not make a big mess, I'm doing it dry. So here goes. All right, the strategy with any kind of sanding is to get the scratches left from the previous grit out before you move on. And always, moving in as much orthogonal directions as you can to try and do that. And so that's what I've been doing here. You can see I've got a little bit of an issue where it's coming up right here. That's definitely not good. One thing with using this is you can't let it get too hot because you'll soften the glue. But I think that I've got most of the scratches out. I mean, it's, again, you look at it from one angle, it all looks pretty good. From another angle, not so much. But what I do see is there is a minute amount of orange peel in there. You can see it. Again, looking at the fringes of the reflection. Okay, but I think that's about as good as that's going to get at the 500 grit. So I'm going to move on. And now that I feel pretty confident that I've got the big scratches out, I'm not going to work each grit as much as I did the 500. Okay, so here we go. And this is where this just really starts to feel like a cruel fucking joke, because you can see I've pretty much got the scratches out of this, but the higher in the grit scale I go and the more reflective this surface gets as a result, the more we start to see this texture. And this is where we start speculating that maybe the glue has something to do with it, that the friction maybe heats it up and starts to make it more nubbly or something. I don't know, but you can see that that's terrible. There's just no way that is going to ever come up to a truly smooth mirror finish from where that's at. I'm trying really hard to get the angles right so you can see just how terrible this is. Because again, I really believe that a lot of what people are calling a really good foil job is just people not being able to see it good enough. And so I'm really forcing the close-ups. But, I don't have to be close up to see how terrible this is. I can see it from a foot away. All right, now I'm going to just do a quick polish here. I know this is going to be a waste of time again, but I just want this, to stand for the record. So I'm going to get this thing going. I'm going to fire that up to about 5,000 RPM. Okay, just get a little bit of polish on there. I'm going to go under the desk to at least start this because I don't want to splatter polish all over everything because it makes a horrific mess. Okay, and this is what we got, and it's I mean, look, it's just obviously horrific. Very nice and reflective. If it weren't for all of the scratches, places where the glue was too thick, and I've sanded through it, but even in between, in areas where it's relatively smooth in terms of scratches or brush strokes, it's still got that horrific orange peel. And it just, that every experiment I've done gets me nowhere beyond this. It's the same every single time. And this is where we start to think that it's the glue. And if that's the case, I just don't know what's gonna be possible beyond that. So anyway, there we go. Okay, so that was pretty much another failure, and after that, I was pretty bummed out. But I went back, and again, I talked to Jen, and we really got into the details of how she's doing it. And I have to say, she understands abrasives at a level that's beyond most model makers. And as it turns out, that's because she used to be an auto body refinisher. So she really understands the nuances of abrasives, and being able to talk through all of that really made the difference, especially looking at her pictures, because look at this. Okay, this is what she got. All right, and this gave me hope, because that right there, that's the goal. She showed it to me at a couple of different angles. You can see, looks really good. If there's any texture there, and she said, it wasn't perfect. And you can kind of see in that picture some of the glue marks. But you know, at least it proved out that it's possible to polish this thicker Reynolds stuff to the level that gets it, you know, at least close to this. And so I followed her exact process, which was what? As it turns out, I think my obsession with machine sanding and polishing was kind of my undoing, because even though I did a real disciplined progression with these little pads, I was over sanding. And the bottom line is that when you get this stuff thin enough, you know, whatever glue texture's under there is going to show. So you've got to be able to flatten it without making it so thin that you run into that. So what I did was I wet sanded it by hand with a piece of 800. This is P800 wet or dry. And I used this to flatten it. And when I say flat, I mean not flat as in not shiny. I mean flat as in level, where the highs and lows have been taken out. Then I came back and again wet sanding. I went to 1,000 grit and then 2,500 grit with these Infini sponge sticks, and got a pretty, and again, got a pretty nice satin surface. Then I just got a little rag and got some of my mother's aluminum polish, and I hand polished it, and I got a pretty decent result. So then I thought, all right, well, if I can get that far by hand, let me see what I can do with a little bit of machine work. So then I grabbed one of these pads, the finest pad, which is the 4,000 grit pad, and just very quickly gave it a quick rub with that on the pin sander, and then immediately machine polished it again with mother's and one of these little wheels. And it looks good. It's not perfect. I was clumsy and I created some scratches, but I got to the point where I feel like there's hope, at least. And this is the difference right here. This is what a real polished aluminum finish gets you that paint is just never going to get you. All right, a really good application of something like All-Clad or any of the really good chrome metallic lacquers will get you pretty decent reflectivity at an inch or two away. But when you get further away from that, you lose it almost immediately. And that's one of the main differences. I mean, you can see that's now about a foot away. I mean, it's easily 15 inches away from my face, and I'm getting good reflectivity. And that's what you get with real polished aluminum. Again, there's some flaws in there. You can scratch this with a fingernail, and that's not good. And I got a few scratches there, and I have a few scratches that were just deeper from the sanding process. But again, overall, I'm not too far from where I was trying to get to, so I feel so much better, because I've been literally fighting this battle off and on for mostly a year now. And here's the whole reason that I'm trying to get to this polished finish, because somebody said, well, look, why do you want it to be super polished? Because, you know, that's, unless it's a polished resto bird, it's not going to look like that. This is the reason, okay? Natural aluminum, brand new natural aluminum sheet is pretty reflective. It's not maybe this reflective, but it's not far from it. The point is, now I've got a polished surface, I can start doing things to it and to give it that real metallic look. Particularly, like what I did, what I wanted to do is get the checkerboard look, okay? And you can kind of see that here when I move it around. You can see that these two panels right here have a slightly different look to them than the panels around. That's because what I did is I just used some Post-it notes to mask those off, and then I polished those differently. I actually just I ran out of space on my card again. Anyway, so what I did is I masked these panels off with Post-it notes and then came back with the 2500 grit stick and just polished on that a little bit. And you can use any, really any different kind of polishing stick. Like you can get one of these nail buffers with the white surface on it and come back and just work different areas. And what you can see pretty quickly is that this is what creates that light and dark checkerboard that you see on an aluminum skin that people try to duplicate using lighter and darker shades of paint, which, yeah, I mean, that's a good way to pretend, but it's not doesn't really give you the real effect, because what happens is if you look, you can see these you can see in these areas where I've been messing with this, where you've got some polishing marks and they become differently visible according to the angle. I mean, this is the whole thing with being able to see the texture from some directions and not as much from others. The other thing that you can do is I've got these little shofu polishers that I got from Rio Grande. They come in a couple of different types, but green and brown are pretty good for soft metals. The green is finer than the brown. But what you can do then is put it on something like a Proxxon, run it at low speed, like 5,000 RPM, and then you can just get in there and selectively work on areas, masking if you need to. So like I can make this little hatch thing right here look different. I can create the appearance of really like in-scale sanding and grinding if necessary. Like over here in this area, I kind of did that just to see, because I had you can see I've got a scratch right there. And so I kind of polished that out a little bit. You can get stuff like this Dialux. These Dialux compounds are pretty cool. They come in different colors. The white is the one that they recommend for non-ferrous. Let me see if I can whip this up real quick. I'll show you this chart. Where's it at? Where was I? Okay, right here. So this is the Dialux polishing chart. So you can see red, green, blue. I've got red, white, and blue compounds. The white is good for pretty much everything, plastic, all these different metals, including non-ferrous, which aluminum is definitely non-ferrous. So I can get on here, get a little bit of this, and these Dialux things are pretty hard rouge, so you got to kind of work to get it on the wheel. Got to be spinning it pretty fast and apply some pressure. But basically all you do is just hog that down on there and get the wheel loaded up, and then come along and polish. And you can see it will whip that into a mirror shine pretty quickly if that's what you want. And again, I'm not really after that as the final finish. That's just an intermediate step, because, I know it seems backwards, but what I'm after is to get to this point and then be able to go backwards to show, what the real characteristic of aluminum sheet is. The other thing that I have to figure out how to do is how to paint this, because I don't want to have to put decals on this. I want to be able to paint the insignia, and so I got to figure out how to get the paint to stick to it, because aluminum as a rule is not friendly to paint. That's one of the main reasons that they used things like zinc chromate primer, was because paint does not adhere to aluminum very well. So what I'm going to try is put a mask on to separate the area where the insignia is going to be, and then try some different chemicals like bleach or maybe a diluted solution of muriatic acid or something that will etch that aluminum back flat and give the paint something to bite onto. So that's the next stage. The other thing that, yeah, so this, I've been working on just trying to get this polished surface. When really that's just kind of the beginning of where I'm trying to get to. And one of the things that's become very clear is that, especially with this thicker foil, that other than the panel lines, my surface detail is not going to show very well. You can see how the rivets, okay, those are the rivets that come in the kit. And you can see how they look just with the aluminum burnished down onto them. And they kind of show, but not, not great. If you really want them to show, yeah, you got to go back and punch every one of them individually with something like this. And that is also going to be a very slow and tedious process. But it is what it is. The main point that I'm hoping to make here is that I've at least now gotten to the place where it makes sense to learn how to do all of these subsequent steps that I need to sort of finish the look. Before now, there just really wasn't any point because I wasn't getting the level of finish on this aluminum that I had to have. And now I feel like I'm there. I feel like there's at least hope. Again, there's flaws in this sample work, but I'm pretty sure I can get beyond that because even with some of those flaws, I mean, you got to admit that is pretty dope, and it's just a place you're never going to get to with paint, at least not in any way that's going to be durable. Okay, so there you go. That's that, and now, yeah, now I have no excuse for not moving on, and that's going to be next. It's time to actually see if I can take this, this struggle and what I've learned and actually turn it into real application on this little Eduard Mustang kit. So that's what's next. Stay tuned. As always, I definitely appreciate you watching. Much love.